Everyone, so today we'll do some jam question, previous year question from this solid state chemistry topic. Generally we can see that from this topic there is only maximum 2 or 3 questions, or in many years it maximum 2 questions are given from this topic, but in some years we can see from 3 questions as well. So I collect some of them from previous year. So let's start. So our first question, it came in jam 2021, that is a monochromatic x-ray having energy 2.8 into the minus 15 joule and diffracted from 200. This is a Miller index. I think you all know this what is Miller index, and of a cubic crystal lattice angle is theta is 8.5 degree, and length of unit cell, and we have to calculate the length of unit cell in angstrom. Okay, and given is Planck constant and the C. Okay, so we have to calculate the unit length, that A is the unit length. Okay, we have to calculate it. So we have energy is equal to h nu. Okay, that is h into c by lambda is equal to E. Okay, then lambda equal to h into c by E, that is 6.626 into 10 to the power minus 34 joules second. We always write this unit because it will help you to calculate easily. And 3 into 10 to the power 10 and meter second inverse. Many students have this mistake. They do this mistake of this unit, so it's always preferable to write this unit with this numbers also. Okay, then E is energy is 2.8 into 10 to the power minus 15 joule. Okay, then second cancel out and joule cancel out. Okay, then meter is there. So if we calculate this one, we'll get 7.09 into 10 to the power minus 11 meter. Okay, we got our lambda, our wavelength. Okay, now we'll calculate. So we know that in lambda sum is equal to 2d sine theta. Okay, we know this equation, and if there is no order is given, so we'll take this, assume that this is a first order diffraction, so n equal to 1. So we have to calculate d is equal to lambda by 2 sine theta. Okay, lambda is equal to 7.09 into 10 to the power minus 11 meter by 2 into, and theta is here 8.5 degree, so sine 8.5. okay, if we calculate this one, we'll get 2.4 into 10 to the power minus 10 meter. These are D. So from this we can calculate our unit cell length. How this is? Because we know D is equal to, okay, this is cubic lattice. Okay, so the equation is a square k square plus l square, or Miller index is 200 plane. Okay, so A will be D, that is 2.4 into 10 to the power minus 10 meter into h is 4, root over of 4. H square is 2 square, 2 square plus 0 square plus 0 square, that is 4, that is 2. So 2 into 2.4 into 10 to the power minus 10 meter, that is 4.8 into 10 to the power minus 10 meter. And we know that 1 angstrom is equal to 1 into 10 to the power minus 10 meter. So this is 4.8 angstrom. Got our answer, that is C, option C. Okay, our next question that also came from in JAM 2021, and that is MgO, that is magnesium oxide crystallize as rock salt. Rock salt means we can assume that this structure is considered as a NaCl. NaCl also a rock salt structure. Okay, we read in our previous video what is the structure of NaCl, and the structure of unit cell length A is given like 2.12 angstrom. Okay, from electrostatic model calculate the lattice energy. Okay, lattice energy you have to calculate. So Na is given, Madelung constant is given, is 0, and charge of electron is given, all is given. So what is the then our what is our equation, the main equation? We know that lattice energy, remember this equation, that is very much important equation, that is 1 by 4 pi epsilon naught minus 1 z plus z minus Na square A by R 1 minus 1 by N. So this is our equation. So what is this? A is Madelung constant. So okay, A is Madelung constant, Madelung or Madelung constant, you can say constant. Okay, R is the distance between cation and anion, is mg here, and O2 minus, and N is Born exponent. Born exponent. We have to know that how we can calculate this one. Okay, so this and E is that E is the charge of electron, Na is the Avogadro number, and is the permittivity that is given, and everything is given, and Z plus Z minus is the charge of cation and anion. So this is our equation. We have to, all are given, just we have to calculate the N. What is the N for our Born exponent number of MgO? Okay, so how we have to calculate this one? Okay, so there is some numbers we have to remember this one. So Born exponent number, Born exponent number of, remember this one. Okay, remember, this is important for inert gas, He, Ne, so neon, argon, krypton and xenon. So for this N is Born exponent. Okay, N is equal to, for He, sorry, helium, that is 5, it is 7, it's 9, this is 10, this is 12. Okay, so we have to know, means is Mg, here it is Mg2 plus. Mg2 plus means atomic number, that is it is 2, Ne as 10 at means electron numbers. Okay, the number of electrons of helium is 2, number of electrons of neon is 10, that is for 18. Krypton have something that is we don't need in this case, that is 36 I think, and that is 54. Okay, this is 54, this is 36. Okay, the number of electrons. So Mg2 plus have 10 electrons, means it resembles like Ne, means neon. So for Mg2 plus, bond exponent number will be 7. Okay, and oxygen 2 minus also have electron number is 10, that is also resembles like Ne. Then the bond exponent number also N, 7. Okay, so total bond exponent number of N MgO, that is 7 plus 7 by 2, that is 7. So if I tell you that calculate the bond exponent number of, okay, bond exponent number of LiCl. Okay, calculate bond exponent number for LiCl. What is that? How you will calculate? So here Li plus and Cl minus. Li plus will resembles like He, because it have 2 electrons, because Li is 1s2 2s1, Li plus that is 1s2, that resembles like He. So for this Li, N will be 5, but Cl minus means Cl have 17 electron, then Cl minus will be 18. So it resembles like argon, that have N will be 9. Okay, so for N, LiCl overall N will be 5 plus 9 by 2, that is 7. So we learned that how to calculate the bond exponent number. This is important. So we have everything. We calculate the bond exponent also too. So we just have to put everything in this equation. Okay, everything in this equation. So lattice energy U, that is defined as U. So 1 by 4 into 3.14 into 8.854 into 10 to the power minus 12. Okay, first is up. Now next minus 1, Mg2 plus all are 2, so 2 into 2. Okay, I think my handwriting is too small. 2 into 2. Okay, so we can do this here. Just a minute. Here we can write. Okay, 2 by 2. Okay, R, what is R? We have to calculate that also. because if we know that the structure of rock salt structure, so we rate that two FCC structure come closer and we take half of the cations FCC structure and half of the anions FCC structure, and togetherly we just interpreted and we just and make that new FCC, or that is not a FCC like, but the FCC of cation and FCC of anion, and it come closer and we'll take half of them also and we build that rock salt structure. So in the plane, in one I am explaining the one surface. Okay, one surface, in one surface, if one surface, okay, assuming that this one is mg and here there is a O2 plus O2 minus, okay, and there is also an mg, okay, here an mg, here mg, here mg. I am drawing just one surface only. Okay, we can assume that here an FCC structure of Cl or O2 minus, and here the FCC structure, or we can this one FCC structure of Mg2 plus, and both come closer and we take half of them too. So all is A, whole is A, okay, from this one. So Mg2 plus and 2 minus, that is A means A is 2.2, so R is R plus R minus, okay, this distance only, that is A by 2, it is 2.12 by 2, 1.06 angstrom. We got our R, so we'll put everything in the equation only. 6.02 into 6.022 into 10 to the power 23. Medullum constant is 1.748 by R is 1.06, okay. We have to that is in angstrom, okay, but we have to know that what is the actual unit 1 by this, and E square is there, okay, sorry, E square is there, E square is into 1.6 into 10 to the power minus 19, okay, that is in coulomb, okay, and last one is 1 minus 1 by 7, okay. I don't know if you can see or not, but you just have to put everything in the equation, and you have to just careful about that equation only, because there is meter, okay, means E0 is meter inverse, so we have to convert it in meter. 10 to the power minus this angstrom is 10 to the minus 10 meter. If you calculate this one, then you will get something like 7880 kilojoule per mole, Okay, this is your answer. You just have to this is a very lengthy process, but do it slowly in the examination, and you can easily do this. Okay. Okay, in this equation question, what is important, that is the equation, the lattice energy, and the structure of rock salt type structure, and the how to calculate the Born exponent. Okay, these are the important things in this question. Okay, our next question is, okay, just a minute. Okay, okay. Next question also, it's came in JAM 21. In JAM 21 there is 3 questions from solid state chemistry. Okay, now what is the calcium crystallized in FCC lattice, unit cell length is 5.56 angstrom, density is there, okay, gram per semi-cube, and the percentage of Schottky defect, and in the percentage they are asking for percentage. Okay, so we can do it in different way, in two ways actually. So if we take in FCC lattice, there is a density, we can calculate as Z is 4, as Z is, because FCC the number of atoms in that crystal, that is 4. Okay, Z we can calculate, assume means by take Z is 4, and the calculate the density, and then we can just subtract the calculated density from this one and take the percentage. Or we can also take the we can take the density, our main basic base, and calculate the Z from, and from that we have to calculate the Z, and we know that FCC have Z4, so then we by subtract that number from Z we can calculate also the percentage of Schottky. But what is the Schottky defect? Schottky defect is that defect that this is stoichiometric defect, means the number of cations and number of anions absent from that lattice, that is same, means same number of cation and anion when vanishes from an lattice or unit cell or a lattice system, then the Schottky defect is can be seen. So from Schottky defect, there is a decrease of density because the number of cations and anions vanishes from that lattice. So we can see the significant number of decrease in density. Okay, now we can calculate. Okay, FCC lattice. Okay, and okay, Z is equal to 4 and A is equal to 5.56 angstrom. Okay, density is equal to 1 point. Okay, density we are not writing here. Okay, and the percentage Schottky defect. So we know that rho is equal to density is equal to Zm by Na cube, A cube. Okay, N is equal to Avogadro number, M is equal to atomic mass, Z is the number of atom present in the lattice, and A is the unit cell length. Okay, so Z we are assuming as Z means basic is, means we take as a base Z is equal to 4. Okay, this method we are calculating. So 4 we calculate the density, and then we subtract the density from this one that is given, and we can calculate the density decrease. Okay, density is Z is 4, M is equal to 4 gram per mole. We always write the unit with this number. Okay, then we can easily calculate the unit at the last one. So 6.023 into 10 to the power 23 mole inverse. That is per mole the number, so it is mole inverse. Okay, A cube is 5.56 into 10 to the power minus 8 semi. So this is cube, semi, cube. Okay, so mole inverse cancel out. So if we calculate this one, we'll get that is 1.5455 gram per semi cube. Okay, okay, and we have this density. Okay, this density means we can see that 1.5455 gram semi cube, and that is the given density is less than this one. So there is a significant number of decrease in density, so we can calculate the percentage of Schottky defect means the decrease of density from the lattice. Okay, percentage of Schottky defect is equal to 1.5455 minus 1.4848 by base is 1.5455 into 100%. Then we will get approximately it is 193.93 percentage. Okay, this is our answer. So we'll do our next question, that is, okay, just a minute, questions are haphazardly okay. Okay, our next question that came in JAM 20, and there is only one question from JAM 20. Okay, question is fullerene C60 is a FCC lattice. Okay, from an FCC lattice, edge length is this one, and with centered each lattice point and smallest distance between the centers of two C60 molecules. Okay, this is our question. So in FCC lattice, what do you know? What is the smallest distance? Smallest distance is in the surface. If this is a surface of FCC lattice, so we know that this is our surface, this is our C60, all are C60, so this is our shortest distance. So this is our shortest distance. Okay, shortest distance corner wise. Okay, so what is so smallest distance there, so smallest distance is, so our corner diagonal is diagonal, if this one is A, diagonal will be root 2a, and smallest distance is root 2a by 2, that is root 2 by 2 into 4.4144 angstrom. Okay, that is approximately 9.99 angstrom. Okay, we can calculate this one by 4.41 by 1.414, that is, okay, just a minute, okay, sorry, 4.414 by 1.414, okay, approximately 9.9, we can say as a, this one is 10 angstrom. Okay, so our next question is come in JAM 19. Okay, so the ratio of nearest neighbor atomic distance in body centered BCC and FCC. Body centered, we got that body centered for BCC smallest distance SD, is equal to root 2a by 2. Smallest distance for an FCC is body diagonal, this is surface diagonal, sorry that is root 3, I'm sorry, that is body diagonal, smallest distance. And for FCC that is 2a by 2, body diagonal, because I am saying this because the smallest distance is this one, so that is body diagonal is root 3a, so smallest distance root 3a by 2. Okay, FCC, so ratio will be BCC is to FCC is equal to root 3a by 2 is to root 2a by 2, that is root of 3 by 2, that is option A. Okay, our next question. Okay, our next question is from X-ray diffraction, that is very important. Okay, so this is a fast order reflection X, this come in JAM 19. Okay, fast order, and the HKL plane is 2 to 0, and observe the glancing angle is, what is glancing angle? If this is a normal, if this is the incident angle, then this one is a glancing angle. Okay, this one is glancing angle, this is incident angle, glancing angle. Okay, glancing angle is 20, means we can as a theta is 20 degree. Okay, so wavelength X-ray is used, what is the wavelength, and they asked for the wavelength. Okay, so our same, this is very same, this we can use that n lambda is equal to just 2d sine theta. Okay, just do that, sine 22 degree. Okay, and d is equal to a by wavelength they asked, and sent edge length is 361. Okay, a by 2 square plus 2 square, that is a square, k square plus 0 square, that is 361 into 10, that is we can use the pm also, we have to calculate this one best. So root 2 square is a 2 root 2. Okay, 2 root 2, that is our d. So in this first order, so n is equal to 1, so lambda will be 2 into 361 by 2 root 2 into sine 20 degree. Bus, just calculate this one, we will get the answer. Okay, you do it yourself, this not very difficult, and this is very easy, just do it yourself. Okay, our next question, that is JAM, this came in JAM 18. Okay, that is very easy, that is the number of crystal system and number of Bravais lattice. Crystal system we know that is 7, and Bravais lattice we know that is 14, so our answer is D. Okay, next question, our next question came in JAM 17. Okay, just a minute. Yeah, okay, our next question came in JAM 17, that is the separation of 1 2 3 plane, that is HKL plane, and orthonomic cell. The orthonomic cell, that is A not equal to B not equal to C. Okay, but alpha is equal to beta is equal to gamma is equal to 90 degree. We can take as a box or matches box as an example of this orthorhombic. Okay, the edges not equal, but the angles are equal to 90 degree. Okay, so we can do it with the equation like d is equal to a by, sorry, not a, or for cubic we can use that a is equal to b is equal to c is equal to, we can but in this case we have to calculate like h by k, sorry, that is h by a square plus k by b the whole square l by c whole square by this h, what is h, 1 by 0.25 whole square plus k is equal to 2 by 0.5 whole square plus l, what is l, 3 by c is 0.75 the whole square. Okay, we can do it by, not we don't have to use that calculator, we can do it yourself. That is 1 by 0.25 means 1 by 4. 1 by 4 means 4 will go upside, that is 4 square. 2 by half, 2 by 1 by 2, that is also 4, that is also 4, that is 4 square. 3 by 0.75, that is 3 by 4, that is also 4, so 4 square. So 1 by 3 into 4 square, that is 1 by 4 root 3. Our answer will be 0.14 nanometer. This is our answer. Okay, easy. Our next question, this is our 9th question, that is came in JAM 16. Okay, this one is also from that X-ray diffraction. We use that here we can, there is 2 theta. 2 theta is given, but in equation we can use the theta only. Okay, not the 2 theta. Just careful about that. The 2 theta is given, not theta. So you have to calculate theta. Theta is 0.8 by 2 degree, that is 10.4 degree. Okay, so we use that n lambda is equal to 2d sine theta. Okay, so we have to calculate the interplanar space separation, that is d. That is d. D means okay, order is not given, so we can assume that n is equal to 1, that is first order. So d means lambda by 2 sine theta. Okay, lambda by 2 sine theta. Okay, lambda by 2 sine theta means 1.54 by 2 into sine 10.4. okay, 10.4 means it is 4.26 angstrom if we calculate this one. Okay, one next and last question of this season. Today's last question is this one. So that came in JAM 16. So potential energy of interaction between two ions in an ionic compound is given, this one, this equation, that is U. Okay, you don't have to write this one. So assuming that CaCl2 is a linear molecule, means Cl minus, Cl2 plus minus. Okay, linear molecule of length 5.6 angstrom. All over length is given, that is 5.6 angstrom. Okay, so this is half, 2.8 angstrom. This is also half, is 2.8 angstrom. Okay, the potential energy of CaCl2 in kilojoule per mole. So the potential, when the potential energy will come. Okay, this is a cation, this is anion. When the potential energy between these two will be negative, and these two also, this Cl and this is also negative, this is also negative. But means I want to say that Ca2 plus Cl minus, there is also a potential energy we will get, that is negative value, because we assume that the potential energy is negative value, that is attraction force between cation and anion. Between cation and anion you have to remember. And Ca2 plus, that is also negative, that is positive and negative attraction energy, attraction force. But Cl minus and Cl minus, there is also a potential energy that is positive, because that is all, both are negative, so potential energy between them is negative, positive. So what is our potential energy of CaCl2? Our potential energy is given by this equation, so we just have to put everything in this equation. So U total is U means potential energy for Ca2 plus Cl minus plus U for Cl minus Ca2 plus U for both Cl minus. Okay, we just have to write this. So how to write? So that is given by 1389.4, that is Z1 Z2 means cation and anion charge, means one is plus 2, it is minus 1 by R, distance between two is 2.8, all is 5.6 but half is 2.8 angstrom. Okay, this is given in angstrom. Okay, plus 1389.4, that is Cl minus minus 1 plus 2 by 2.8 plus U for this one 1389.4 minus 1 by, you can see that this is negative value, because they both are attraction force, but this is repulsive force, that minus minus is positive, so this whole value is positive for this one. So whole is Cl minus to Cl minus, that is 5.6. okay, you just have to calculate this one. By calculator we can get 1736.75 kilojoule. Okay, so it may be by this equation many of students may ignore this question, but this is very easy. You just have to calculate this 3 you all, many of students that they calculate these two, but you can easily ignore that this potential energy, but you have to calculate this also with this. By this we will get this answer. So this is also important question that came in Gen 16. So by this, so I did some important question from previous year question. You can see that some repeated question like that this very important equation n lambda is 2d sine theta. X-ray diffraction is very important topic for JAM perspective, and there is also something like this one is important. Lattice energy calculations is sometimes is given, and nothing important is given by previous year question. Nothing important, you can easily do it. You just have to remember some equation. Okay, by this I am ending this session. Do well and practice these questions. You can easily crack JAM. Don't worry, from this topic there is maximum 2 or 3 questions. Sometimes in some rare years we can see that 3 questions, but in generally we can get the 2 questions from there, but they are very easy. Okay, thank you. I'm ending this. Bye bye.